We have studied about the Heisenberg's uncertainty principle, de Broglie's hypothesis, and we have seen the reasons for the failure of Bohr's model. Now we will discuss the limitations of Bohr's model and we will start quantum mechanical model of atom. So, limitations of Bohr's model. So, the first limitation of Bohr's model can be written as advanced spectroscopic techniques revealed the splitting of lines of hydrogen spectra into fine structures. Which could not be explained by Bohr's atomic model. So, and the second point was Bohr's model failed to explain more complex structure of atoms having multiple electrons. So, the first point is advanced spectroscopic techniques revealed the splitting of lines of hydrogen spectra into fine structures, which could not be explained by Bohr's atomic model. So, when Bohr's model was established, it could perfectly describe the hydrogen spectra. It could perfectly analyze the lines of hydrogen spectra and it had provided the equations for its wave number as well as energy. And the hydrogen spectra was divided into various series like Lyman, Balmer, Paschen, Brackett and Fund. We have discussed them earlier. But when spectroscopic techniques became more advanced and new techniques evolved, it was observed that the single lines that were observed in the hydrogen spectrum earlier were not single lines at all. There were finer structures and multiple lines within these single lines. So, now this could not be explained by Bohr's model anymore. So, this was one limitation. And the second point was that Bohr's model could not be extended to other heavier atoms. We have mentioned multiple times that Bohr's model is applicable only for hydrogen or hydrogen-like systems like helium plus, lithium 2 plus, beryllium 3 plus, etc. So, only the single electron systems could be explained by Bohr's model. But naturally, every element in the universe is not single electron, right? Only hydrogen atom is single electron. And for the other few elements like helium, lithium, beryllium, etc., Bohr considered them in the ionic form, that is by eliminating all other electrons and taking only one electron. But for example, if we take the lithium atom or the beryllium atom, lithium atom has 3 electrons, beryllium atom has 4 electrons. So, it is not possible to explain these multi-electron system with the help of Bohr's model. Also, there are various heavier atoms also. So, this could not be explained by Bohr's model because it was applicable only for single electron species. So, this was a huge limitation of Bohr's model. Now, the third limitation was Bohr's theory could not explain Zeeman effect and Stark effect. Now, what is Zeeman effect and Stark effect? So, Zeeman effect is splitting of spectral lines of an atom into finer components in the presence of a magnetic field. So, Zeeman effect is the splitting of spectral lines of an atom into finer components in the presence of a magnetic field. That is, if this is a single spectral line, then in the presence of magnetic field, it splits up into various component lines. So, these splitting could not be explained by Bohr's effect. This is known as the Zeeman effect in presence of magnetic field. Okay. And what was Stark effect? Stark effect was similar to Zeeman effect, just in case of electric field. So, Stark effect is the splitting of spectral lines of an atom in the presence of an electric field. So, in Zeeman effect, a single spectral line splitted into various component lines in the presence of magnetic field, and in the Stark effect, a single spectral line was splitting into component lines in presence of electric field. This was called Stark effect. So, Bohr's theory could not explain these two phenomena, that is Zeeman effect and Stark effect. And a very important limitation, the last one was that Bohr's theory could not explain the details of bond formation of atoms to form molecules. This was a very serious limitation of Bohr's model, that if we have only the knowledge of atoms, then it is not sufficient. We need to know about the molecules also, that how various atoms bond with one another to form a molecule. The details of bond formation or the mechanisms of bond formation could not be explained by Bohr's model. So, due to these limitations, later on the theory of quantum mechanical model of atom was proposed. Now, it was observed that Bohr's model mostly failed because it was based on the classical physics. But with the discovery of de Broglie's hypothesis, where the matter have both wave nature and particle nature, and Heisenberg's uncertainty principle, it was revealed that very small microscopic particles like the atoms or electrons, they do not behave in a similar way like a macroscopic element. Like in classical physics, we generally talk about a ball or a block or a box or some macroscopic elements which are visible with eyes. But when we are talking about atoms or electrons, they are microscopic and they are so small that their behavior is not similar to the macroscopic elements. So, the theories of classical physics which could explain the behavior of macroscopic elements were not sufficient to explain the behavior of microscopic elements. So, a special branch of physics was evolved to describe these phenomena. That was called the quantum physics or quantum mechanics. And with the evolution of quantum mechanics, the behavior of electrons and the structure of atom could be described in a new way. So, now we will discuss about the quantum mechanical model of atom. So, quantum mechanical model is till now the most widely accepted atomic model. So, in the modern times, in present times, all the theories about the atomic model, all the calculations in chemistry and physics are based on the quantum mechanical model. So, this is the most widely accepted atomic model. It was developed by Erwin Schrödinger. Erwin Schrödinger, and it is based on quantum mechanics. Quantum mechanics, which explains the behavior of microscopic particles such as atoms or electrons. Okay. And the quantum mechanical model also explained duality of matter and Heisenberg's uncertainty principle. So, from the beginning of this lecture of structure of atom, we had first read the Dalton's atomic theory, then we had Thomson's plum pudding model, then we had Rutherford's atomic model or the nuclear model of atom, then we had Bohr's model, and finally we have come to quantum mechanical model. So this one is the final one. So we will start the quantum mechanical model. So Erwin Schrödinger proposed an equation which is applicable for microscopic systems whose energy does not change with time. So this equation was written like this. This was the simplified form of Schrödinger equation. Now we will not study the exact solution and derivation of these equations now, because it contains some higher mathematics and it will be there in higher studies, but for this level we will just discuss about the features of these terms. So first of all, so here some new terms are introduced. This term H with this symbol, it is the Hamiltonian operator. So what is an operator? So an operator is some entity which decides any operations that can be carried out. Like in mathematics, we read about addition, subtraction, multiplication, division, plus, minus, all these are operators. And in some higher mathematics, we have also learned about derivations or square, integration. All these things are operations. So operators denote the operation of a function. So H is called the Hamiltonian operator, which carries out double differentiation of a quantity. So this is the Hamiltonian operator which carries out double differentiation. That is d2 dx2. This is the operation of double differentiation. Hamiltonian operator carries out double partial differentiation, which is written by delta 2 by delta x square. And what is psi? Psi is the wave function. Okay, this is a Greek alphabet, Greek letter, which is pronounced as psi. Okay, so psi is the wave function and E is the total energy. Next we will study in details that what is the Hamiltonian operator, what is a wave function, and how the energy terms are calculated from this. Thank you.